In this lesson we're going to look at how to find the equation of a straight line. Now when we write our equation, we're going to write it in the form y equals mx plus c. Now the value of m represents the gradient of the line, and we're going to do that as our first step. Once we've found the gradient, our second step is to find the y-intercept. In other words, where the line crosses the y-axis on its way up or its way down. If the line's heading upwards as we move to the right, we expect to have a positive value for m, a positive gradient. If the line is heading down as we move to the right, then that would be a negative gradient. In our first example, we're actually going to be given the value of the gradient and the value of the y-intercept. So in this case, the gradient's 3/4 and the y-intercept's 8. So we can simply write the equation down directly as y equals 3/4 x plus 8. So the gradient is placed in front of the x, and the y-intercept is the number that sits there by itself. In our next example, we'll find the equation of a straight line, this time after being given a graph. And so when we look at step 1, which is to find the gradient, we look at the line to see if we can work out how steep it is. Now we notice first of all that that line is heading upwards as we move to the right. So we're starting across here and we're moving up as we go to the right. Now if we just pick out a section of that line, and a good section to use would be from here to here, we can see that as the line moves up, it's moving up a distance of 8 units, and the run is 4 units. Now the run is always positive. Even though we're starting here at -4 on the x-axis, we're always moving forward, so that's actually a positive 4. Now it probably pays just not to worry about that negative sign there for the moment. Just look at the actual distances involved. A rise of 8, and this way a run of 4. Okay, so our gradient is going to be 8 over 4, which gives us 2. The next step is to find the y-intercept. And in this case, we can see that the y-intercept is actually labelled on our graph, and it's a value of positive 8. So in our equation, we write y equals 2x plus 8. The next example, we're going to find the equation of a straight line with a gradient of -3 and which passes through the point 4, -2. Now, if we have a look at what's happened with the working here, we can see that because the gradient was -3, I've written an m above that value, and the other numbers given in the question are the 4 and the -2, which represent a single point. So the x value is 4 and the y value is -2. So when we write down the equation as y equals mx plus c, we will now fill that out with the information that we know. So the y value we know is -2. We replace m with the value of the gradient, which we listed up here, -3. And the x value of our point is 4. So we write -2 equals -3 times 4 plus c. So now we can go ahead and find c. Our next line, we can see that we've multiplied this -3 and the 4 to give a -12. And to get c by itself, we're going to take this -12 value and take it across to the other side of the equation. So we've now got -2 plus 12 is what c is equal to. So c is 10. We can now write down the equation as y equals -3x plus 10. Now, if we're not given the gradient, or we can't see it from a graph or work it out from a graph, we're given a bit of extra information. In this case, we're given the coordinates of 2 points. Now you'll notice that because we've got 2 points, I've given each of those x and y values for the points a subscript. So this is x1, y1. This represents one of the points. Our second point is labelled as x2, y2. Now it doesn't really matter which point you call point 1 and which one you call point 2. But again, our first step is to find the value of the gradient m. Now because we've got those 2 points, we can use our formula to find the gradient. We can't do it from a graph because we don't have a graph, so we'll use the formula. So the gradient formula says y2 minus y1, which is the difference in heights of those 2 points. So this is the rise, is divided by the run, which is x2 minus x1. So we substitute the points in to find those values. Let's have a look at what we've done. We've started off by saying y2 minus y1, and we've got those values from the points. y2 was 19 and y1 was 4, and we minus. 19 minus 4 gives us our 15. x2 minus x1, we've got to be careful, we are minusing them. x2 is a 3, and we're going to minus from that the value of x1, which is minus 2. So when we do a minus of a minus, we get a plus, so we're going to add 3 and 2 to get 5. So 15 divided by 5 gives us a gradient of 3. So we've got the gradient, that was step 1. To find the y-intercept, again we can't read this from a graph, but we do know that the equation will be written in the form y equals mx plus c. So to find this value of c, we need to substitute in a value of y, the gradient, and a value of x from the same point. Now we've got 2 points to choose from, so it doesn't really matter again which one we use, but I'm going to use the x and y values from the second point. So when y is 19, x is 3. So when I substitute in here, I replace y with 19, I replace x with a 3, and of course the gradient was also 3. When you substitute a value, it's useful to put it in brackets, and that indicates that we need to multiply these 2 values together. So the y value of 19 is equal to 3 times the x value, 3 times 3, which is 9, plus the value of c. To get c by itself in this equation, we're going to take this 9 across to the left-hand side of the equation over here, so that we now have 19 minus 9, so giving us a value of 10 for c. Now recall that we know the gradient now is 3, we know that the y-intercept is 10, so we write our equation as y equals 3x plus 10.